Here is a graphical representation of the solution of problem 2. The graphs are enclosed by a 10 by 10 by 10 cube with the origin of the coordinate axes at the center. The graphs of equations 1, 2, and 3 are planes, 1, 2, and 3 respectively. Each pair of planes intersects in a line. The three lines intersect at our ordered triple, 1, -4, 3. That's the solution of the system. You can also use substitution to solve a system of three equations. Substitution is the best method to use when you can easily solve one of the equations for a single variable. Problem 3. Solving a system using substitution. This one's multiple choice. What is the x value in the solution of the system? Our choices are A1, B4, C6, and D10. Step 1. We can choose an equation that looks easy to solve for one variable. In this case, equation 2 is chosen and we'll be solving for x. Solving for x in equation 2, we find that x equals 9 minus 5y. And in step 2, we'll substitute the expression for x, that 9 minus 5y, into equations 1 and 3 and simplify. So in equation 1, having substituted, we get the equation 2 times the quantity, 9 minus 5y, plus 3y minus 2z equals -1. So we've eliminated x's from this equation, and now we have an equation with only y's and z's, which simplifies to -7y minus 2z equals -19, and that's labeled equation 4. Doing the same in equation 3, 4z minus 5x equals 4, substituting 9 minus 5y for x, we simplify and get the equation labeled here as 5, 25y plus 4z equals 49. So pairing these two, we have a new system of equations that only have y's and z's. So step 3, we'll write the two new equations as a system and solve for y and z. Here are equations 4 and 5. And notice if we multiply equation 4 by 2 and then add equations 4 times 2 and equation 5, our z's are eliminated and we end up with 11y equals 11 or y equals 1. Next, we'll substitute the value of y into equation 4. So instead of y now, we'll write 1. We get -7 times 1 minus 2z equals -19, which works out to be z equals 6. Step 4, well, now that we have y and z, we'll use one of the original equations to solve for x. Here equation 2 is chosen. Substituting 1 for y, we have x plus 5 times 1 equals 9. So x equals 4. We can now state the solution of the system is the ordered triple 4, 1, 6, and x equals 4. So the correct answer is B. Your turn, part A. What is the solution of the system? Use substitution. And part B, a reasoning item. In problem 3, was it necessary to find the value of z to solve the problem? Explain.